All right. Your entire life, when somebody said, what is the measure of this angle, you would always tell them an answer in degrees, wouldn't you? It's always something degrees. An angle always measures something degrees. Well, that changes today because there is a second way you can measure an angle. A second way. You can do it in degrees, which is what you're used to, or you can do it in what's called radians. You can measure an angle in a radian. And that's what we're going to talk about today is what's a radian and how do I convert it. Also, you guys remember your Regents days, math Regents days, when at the beginning of the Regents, your teacher would be like, all right, guys, clear your calculator, probably in that type of voice. Clear your calculator. And you guys, you would clear it, and then you'd have to go back to mode and put it in degree mode. Do you ever see what the other one was next to degree? It's radian. Okay, it's radian mode. All right, because that is the other way to measure an angle. Don't touch your calculator. Don't worry about that. All right, but that's just to show you that why that radian is on your calculator like that. It's another way to measure an angle. So let's talk radians. How do I know if an angle is being measured in radians? Here's the key. Ready? Hey, ready? You're going to see that little symbol right there, that mathematical symbol, which is pi. If I see a pi in my angle measure, I know it's in radians. Okay, so if I see a pi in my angle, oh, that's it being measured in radians. What I need you guys to have the ability to do today is take that radian and tell me what it would be in degrees then. Because there's certain problems we're going to do later on this week that have to be in degrees, certain problems that have to be in radians. So how do I take 7 pi over 6 radians? And I do want to show you this, even though I know probably 99% of you won't care. I do want to show you this. Why is the pi there? Here's why. Take quickly here. If I do 7 pi over 6, I don't think anybody wants to write that number out. Okay, so instead of writing that sloppy decimal out, they clean it up and they put the pi in there instead to clean it up a little bit. But that's how many radians we're talking about right there, 3.66 and change. All right, but we don't want to write that, so we clean it up and put the pi there. All right, so how do I turn it into degrees? On your reference sheet, if you look at your reference sheet, you will see a little column that says radians. So look at your reference sheet right now. Boom, there it is, radians, correct? Everyone sees the radians? And it'll say 1 radian is equal to 180 over pi degrees. That 180 over pi is what we're multiplying the radians by. 180 over pi. And I'll go through that one more time before we find the final answer. You started problem number 1 out in radians. So you went to your formula sheet and you found the column that said radians. It gave you a fraction, 180 over pi. You multiply 180 over pi by your radians. And watch what happens, kids. Watch this magic. Do you see what's on top and bottom? That's going to cancel out. What's on top and the bottom that will cancel each other out here? Go ahead, Bassett. What's on the top and bottom that'll cancel each other out?
Pi.
Yep, they're gone. And now all you guys have to do in your calculator is 7 over 6 times what's left in the parenthesis, 180. So we go to the calculator, 7 over 6 times $1.80. And it'll tell you 210 degrees. So this is equal to 210 degrees. So 7 pi over 6 radians is the same as 210 degree angle measure. All right. Questions there? Okay. What if I wanted to go in the other direction now? So in number 2, it's 120 degrees. What if I wanted to go in the other direction and say, okay, kids, what would that be in radians now? How many radians is 120 degrees? Okay. So I got 120. Now on your reference sheet, you want to go to the column that says degrees. So everyone, boom, find where it says degrees. If you don't have a reference sheet, I have it up here already. Now it's saying multiply by what fraction? Pi over 180. I'm going to multiply by pi over 180. Don't you dare go to your calculator yet. Don't you dare. Because, well, hey, you guys go to your calculator right now? Okay, so you want me to do 120 times pi over 180. What did we just talk about? I don't want that to write down. That's sloppy. I'm not writing down that decimal. So what you want to do is keep the pi in your answer. Because remember what I said at the beginning of class. How do I know an angle's being measured in radians if they don't tell us? You're going to see the pi. You're going to see the pi there. Oh, that's radians. What I do need you to do, though, is take the 120 you have on top and the 180 you have on the bottom and reduce that sucker. 120 over 180. Keep the pi right there, but I need you to reduce 120 over 180. Huh? Reduce? Oh, that's going back to elementary school. Guy, your calculator, I've been trying to stress this to you all year. Your calculator reduces for you. All you got to do is plug in the fraction you want to reduce. 120 over $1.80. And it'll reduce it for you. 2 over 3. So what is 120 degrees in radians? 2 pi over 3. Which is the same as that sloppy decimal up there, 2.0943. Same thing. Hey, you guys good? How we doing? So if you're given radians, you go to where the column says radians in your reference sheet. If you're given degrees, you go to degrees on your reference sheet. All good? I'm not going to spend any longer on converting because that's what all your delta math is today. It's just converting from one to the other. All right. Sometimes, though, radians don't always have pi in them. Okay, sometimes radians don't have pi, but I still want you to turn it into degrees for me. All right, so take a look at A. Oh, we got a little friend here we got to talk about. We've talked about sigma. We've talked about beta. I want to introduce you to a new Greek symbol. Anybody know what this Greek symbol is called? Begins with a T. Never seen it before? That's fine. Theta. This is one that will stick around for a while. Theta. And remember what? Don't get freaked out. All it is a variable. X. It's like X. It's like Y. It's just a variable in Greek symbols. So they're saying I have 5.8 radians. 5.8 radians. How many degrees is it? So everyone go to the reference sheet. Look where it says radians. What should I be multiplying 5.8 by here? Look where it says radians. What should I multiply 5.8 by? Let's go. Katie, what should I be multiplying it by? What's it say on the formula sheet where it says radians?
Pi over 180.
I think, go ahead. I think
180 over pi.
There you go. 180 over pi. Now, in problem number 1, remember Bassett told us we could cross out the pi's? Well, you can't do that here, can you? There's no pi's to cross out. So all I'm going to do now is go to my calculator and multiply those two. 5.8 times 180 over pi. The pi just doesn't cancel out here. It just doesn't. There's nothing to cancel it out with. Sometimes it will, sometimes it won't. So 5.8 times 180 over pi gives me a long decimal, but I gave you guys rounding directions here to help you out. So round your answer to the nearest degree. How many degrees are in 5.8 radians? 5.8 radians. How many degrees? What do you got for me there? 12. Dan, what do you got for me? How many degrees?
There's 332.
Yep. 332 degrees and 5.8 radians. Whew. Everyone all right? Okay, one more just to make sure we're good. Now I gave you negative 2.5. I don't care that it's negative. Don't get rid of it. Keep it. There's no reason to get rid of it. Keep it. So I'm going to take negative 2.5 and multiply it still by 180 over pi. There are no pi's to cancel. No pi's are canceling here. So I'm just going to go to my calculator and multiply the two. And I'll give you guys a second to do that before I ask somebody. When you're ready, take your time. Nick, when you're ready, take your time. Let me know how many degrees. Negative 2.5 radians.
Negative 143.
Yep. There you guys go. It's not bad at all, considering you're going to be given that reference sheet anytime you need it. Okay? Anytime you need it, you can have that reference sheet in front of you. You just got to know which one's the correct one to pick, right? All right, everyone all good before I go on to something else? All right, read through number 4. Find an angle that's positive and an angle that's negative that are, ooh, that's why I went over that vocab word. Coterminal to this angle. Well, hey, quick review, going back. Remember coterminal? I think it was Colin said, hey, to degrees, you can add or subtract 360 to them. Okay, always add or subtract 360 to find the new coterminal angle. Well, there's an issue here, isn't it? My angle's not in degrees, it's in what? 5 pi over 2, that's in what kind of measure? Ooh, 7, here we go. Will, what type of measure is 5 pi over 2? It's not degrees, it's what?
Radians.
Radians, right, guys? So adding the 360 and subtracting 360 won't work here. That's for degrees. So what I'm going to do right now, I should probably have you guys do it on your own, but just for time's sake, so you can get to the assignment. What is 360 degrees in radians? Because you're going to need this conversion now. And this is something you'll just start picking up big time starting tomorrow and Wednesday. It's equal to 2 pi radians. 360 is equal to 2 pi radians. All right. So to 5 pi over 2, we're all good. You're not going to add or subtract 360. You can't mix degrees and radians. So I'm going to add and subtract its equivalent. So here you go. 5 pi over 2 plus, not 360, that's for degrees, but instead add 2 pi. 360 in radians is 2 pi. Everyone see why I'm adding 2 pi now? Okay, radians, I got to add 2 pi. Degrees, I would add 360. Oh boy, you're not going to be happy here, huh? 2 fractions without the same denominator. Oh, I hated that. I was never good at that. Relax. Relax. What's the darn denominator here? 2 and 1. Can you find a common denominator now? I hope. Common denominator of 2 and 1. 2. It's not that bad. 5 pi will stay 5 pi, right? Because it's already got a denominator of 2. So 5 pi will stay 5 pi. The only work you have to do is what are you going to multiply 2 pi by? Remember, it's got a denominator of 1. So what should I multiply that 2 pi by? 2. Oh, Isaiah. I got a common denominator of 2, Isaiah, but this has a common denominator of 1. So what should I multiply it by?
2.
Yep. So 2 times 2 pi. What do you got, boss?
4 pi.
4 plus 4 pi. Everyone all right? Not that bad. All right, add your tops. What do you got? 9 pi over 2. There's your positive angle. There's the positive angle. Everyone all right? right, 9 pi over 2. All right, now I need a negative one. So what's your suggestion right now? What should I do with 5 pi over 2 now to get to the negative version of it? I added 2 pi there to keep going positive. Thoughts? 6. Mason, what's your thoughts there, boss? What should I do now to find the negative angle?
Subtract the 4 pi.
Yep. Oh, let me get there first. So I'm going to subtract 2 pi here. Right? Add and subtract 2 pi. All right, nothing's changing, guys. Still a denominator of 2. I still have 5 pi and 4 pi, but now I'm just going to subtract them. Uh-oh. Anybody seeing what's going to come up here? Uh-oh. Uh-oh. Because what am I going to have here? 5 pi minus 4 pi, which is pi over 2. What's the problem? Why did I not follow my own directions here? What's the problem with pi over 2? What do you got, Eliana? What's the problem with my pi over 2?
Wouldn't it be like a negative?
Well, no, it's still positive. That's the problem. It's not negative. I need a positive answer, which I got right here, and I need a negative answer. But I ended up with positive pi over 2. So keep doing what? Keep doing what, guys? Subtract another 2 pi until you get there. Keep adding or subtracting 2 pi till I get the result I need. Okay, stuff's not going to change here. Here you go, Nick. Back to you. What's still my common denominator?
2.
2. Do I need to multiply that pi by anything here?
No.
Nope, because it's got a denominator of 2. What do I need to multiply 2 pi by? Remember, it's got a denominator of 1, so what do I got to multiply it by?
2.
2, so it's going to be, again?
4 pi.
Yep. And then, guys, take a look. I'll get my final answer, which is what? Pi minus 4 pi? Negative 3 pi over 2. There's my negative version. All right? So again, keep adding 4 pi or keep subtracting 2 pi till you get both versions. And I'm pretty confident you should be able to handle the fractions here, even though they don't have the same denominators. Anything you guys want to ask before we get to the last problem and I let you go on your own? All right. Before I get to the last problem, did anybody have an issue of graphing 260 degrees? Could you graph that? Tell me it's in the third quadrant by now in the unit. Because if you can do that, you can do this last problem. Now I want you to still graph, but now it's not in degrees anymore. It's in radians. So graph an angle that's negative 5 pi over 6. Guys, I just asked you if you had any issues graphing in degrees. Do you? You have any issues graphing in degrees? Then turn it into degrees. Take negative 5 pi over 6, convert it, like we did at the beginning of today, and graph it. Okay? There's no reason you have to always stick in radians. You can convert back and forth. So let's see if we remember how to convert. So negative 5 pi over 6, what would that be in degrees? So look at your reference sheet where it says radians, because that's what I was given. And I need somebody to let me know, what do I need to multiply by here? What's the reference sheet tell you to multiply by? If I need degrees. Oh, that boss. Mason, here we go. Going back to you. What do you need to multiply by?
180 over pi.
Great job. You guys are doing awesome today. Usually, kids get confused on where to look on the reference sheet. It's whatever you're given. If you're given radians, darn it, look at the left side and see where it says radians first. All right, pi's cancel out in this one. They do cancel out. So I will let you guys go to your calculator and do negative 5.6 times $1.80. When you get it, let me know. What is it in degrees? When you get it, let me know. I've heard enough from you, Mason. You're good. Hunter's on fire today, not even here. There we go. Bassett, back to you. Last one for you. What'd you get in degrees?
Negative 150.
Good job, bud. Good job. Negative 150. Are we comfortable graphing negative 150? If you're not, add 360 to it. That's your preference right now. I'm sticking with negative 150. All right. If you're not comfortable with it, go ahead, add 360 and see what the positive version is. Negative 150. Remember, we're going clockwise now. Clockwise. What quadrant does negative 150 end up in? What quad? Katie, what quadrant am I in? Negative 150.
The third.
Great job. Third. Closer to 180. Remember your arrow here. It's got to go clockwise. So it's not that bad, right? Sketching it in radians. I just turn it into degrees and I'm good. There's a second part to this question, though. What's the reference angle? And that has to be in radians. What's the reference angle? Well, can you find it in degrees? And then we'll just convert it. All right, there's no shame in finding it in one way and converting it into the other. So what is my reference angle in degrees here? Well, where is the reference angle? Terminal side, x-axis. What is that reference? Remember, it's got to be positive less than 90. So I need to hear from somebody. What are you going to do? What numbers are you going to play around to find that reference angle? Okay, remember that was 180 right here. This is negative 150 here. Or you could go around the other way and find out what it is in the positive direction. Thoughts? Because you got to be at this point here. 13, what do we got? Sophia. I didn't think. Nope. Hunter's going to owe me a lot. Eliana, go ahead. Thoughts? What numbers do you want to play around with to find the reference angle?
Would that be 180 and 270?
Well, you don't want to use 270 here because that's on the y-axis. Okay, remember, I know we went in a negative direction here, but this is still 150 degrees going this way. Still 150 degrees, right? So you could take your 180 and subtract that 150 from it. If some of you guys, I don't, what is it? Anybody find what it is in the other direction? 210? 210, yes, in the positive direction. You could also do 210 minus 180 if you wanted to do it that way. All right, so this ends up being 30 degrees, the reference angle. But what did the direction say? Leave it in radians. So we got to convert before we end the day here. So let's take 30 degrees. Got to leave it in radians. So what can we multiply by here? Go to your formula sheet. Look where it says degrees now on your formula sheet. What's it say to multiply by? Bassett, what are you going to multiply by?
180 over pi.
Oh, easy, easy. You're going in the wrong direction. I have degrees, Bassett. So look on the reference sheet, left side or at the beginning of today's notes. If I have degrees, what is it?
Pi over 180.
There you go. Pi over 180 if I'm given degrees. Remember, radians have a pi in it most times. Keep the pi in your answer and just go to your calculator right now and reduce 30 over 180. 30 over 180 in your calculator. And when you're ready, what's that reduced down to? 30 over 180. I should have known. There we go. Colin, what's it reduced down to? 30 over 180. freeze up on us? All right, we'll get this answer sooner or later. There we go. Kian, there we go. What's up, boss? Pot 30 over 180. What do you got?
1 pi over 6.
Yep, 1 pi. You can have pi over 6, 1 pi over 6. It's up to you. All right. I'm going to save part B to review beginning of class tomorrow because I want you guys to get to the Delta Math assignment. Just so you guys know too, I just want to make sure I'm open about everything and honest with you. I can check to see how much progress you've made because you go until you get 100% on all the assessments, all right? So Bassett, when you have time, you want to make sure you watch the video from Friday and try to do that assignment. Colin, you need to get 100% for me from Friday's assignment. All right, we're at 67% right now. I need it to be 100 if I'm assigning a Delta Math one, guys. Okay? All right, get after it, 3.3. Any Delta Math assignment should have 100% with it because you get multiple tries.